Hey guys, Mr. Martin back here again with today's video on how to use congruent triangles. Let's start out with a definition. You guys remember, by definition, congruent triangles have corresponding parts. You remember when we were talking back in one of the earlier videos that all 6 pairs of angles on congruent triangles have to be congruent to each other? So in other words, there's 3 pairs of angles and there's 3 pairs of sides. That's 6 pairs have to be congruent to each other. Well, those pairs are called corresponding parts. So if we can prove that the 2 triangles are congruent, you know that the corresponding parts must be congruent as well. So that's why we've been working so hard on proving 2 triangles are congruent, because we wanted to be able to use this information to make decisions about things that we didn't know necessarily were true. Got 2 pretty cool examples to show you, and we'll use this information. Let's get started. Alright, example 1. I think you know as well as I do that that hang glider is symmetrical. But I want to prove that QT, the beam going from the middle to the, guess that would be the right wing, right? Depending on if you're looking up at it or down at it. And ST going on the other side, I want to prove that those 2 beams are congruent. Makes sense that they are, but I want to actually prove that they are. Alright? So let's figure out how are we going to do that. So if we can show that triangle QRT, let's mark that triangle. It's this triangle right here, QRT. Okay? If we can prove that that triangle is congruent to triangle SRT, let's mark that triangle, SRT. Okay? You will know that QT is congruent to ST. Okay? So, the first thing we're going to do is we're going to copy down the diagram so that we've got some triangles that we can actually manipulate, right? And then we'll go from there. So let's copy down the diagram, and then once we do that, we're going to mark up the information that we know has to be true based on information that we already know is true. Alright? So let's take a look here. So, we've got some lines that we extended, namely RQ and RS, and those form those exterior angles, right? And if you remember from linear pairs, those 2 angles on each side are going to be supplementary to each other. So these 2 angles are going to be supplementary to each other, and these 2 angles are going to be supplementary to each other. Alright, so now we know that 1 is congruent to 2. Well, we could prove that because 1 is congruent to 2 and they're both supplementary to each other, right, that those 2 angles, RQT and RST, have to be congruent to each other. Okay? And also, the good old reflexive property is going to help us out again. RT on the left triangle, namely RQT, has to be congruent to RT on the right triangle, namely RST. So look what we have now. We have an angle, which is the blue angle inside. We've got the red angle inside, and we've got a side now. So we've got angle, angle, side. Be careful, this is angle, angle, side, not angle, side, angle, because the side is not included, right? It's not the side in between. Okay? The side in between, okay, would have to be ST, because it's in between angles T and S, right? Okay, so since we know those 2 triangles have to be congruent to each other, we know the corresponding parts are congruent as well. And the short way we can write that is something that's called CPCTC. That stands for corresponding parts of congruent triangles are congruent. That's the letters right here. Corresponding parts of congruent triangles are congruent. It's a pretty neat acronym. It saves us from having to write 5 words, right? Alright, let's keep going. Okay, want to show you another example. When you cannot easily measure a length directly, meaning you can't take a tape measure and measure it, you can make a conclusion about the length indirectly. We call this indirect measurement, usually by calculations based on known lengths. So let's look at a very common. I want to know how far it is from point N to P. What should we do? Maybe we should get a guy that can swim really well, give him a tape measure, and have him just pull the tape measure across from one side to the other. Yeah, that won't work, right? Oh, how about this? We can use a cannon. We'll launch a rope from side P, or from point P, and we'll launch it over to point N. The guy will catch it, and we'll mark it, and then we'll pull it back to the other side, and we'll measure the rope. No, that doesn't sound like very common sense either. So we need to find a better way to tell me how far, if those are two cities, they are from each other. Probably not two cities. Let's say maybe two ports where, or how about this? You know what? That looks like that could be the distance from the shuttle stop at P and the shuttle stop at N. There's a shuttle boat that runs back and forth between Oakland and San Francisco. Maybe that's the distance between those two stops. Huh. Maybe. I don't know. But that looks like that could be the San Francisco Bay to me. All right, let's take a look at this problem. Okay? So what we're going to do, have you ever heard of a surveyor? You ever seen those guys on the side of the road? They usually have a pole. One guy's got a pole, and the other guy's got looks like a camera-looking thing or binoculars they're looking through. Yeah, those guys are surveyors. So let me show you how they do something like this using surveying equipment. Okay? First thing they're going to do is they're going to place a stake at K, right here at K. Okay? And they're going to they're going to place that stake so that NK is perpendicular to NP. Okay? So they're going to put it at one point. We know that perpendicular to any one line through any one point, there exists exactly one line. In this case, it happens to be NK. Okay? Now we're going to find the midpoint of that new segment. We're going to call that midpoint M. So we know that those two little pieces are congruent to each other. Okay? Now we're going to locate point L so that it is perpendicular. So LK is perpendicular to NK. So we're going to have a right angle right there. Okay? What we're going to find is that points L, M, and P end up being collinear. So we can actually draw a line from L to P. So I'm wondering, how can we use this information to actually find our original question? We want to know how far is it from N to P. We want to find the length of that segment right there. So how are we going to do it? I think you can start to see we got some right triangles that are already forming here. Do you see the two right triangles? Right? We got two right triangles. Let's use a color that really stands out here. Let's do that right triangle and this right triangle. Since we're talking about using congruent triangles, I'm thinking we're going to prove those two triangles are congruent. Once we do that, we've got a length that we can actually measure on land, namely L to K, right? Once we figure out what that distance is, that's obviously going to be congruent to the other side, which was NP, the original distance from N to P. So let's do it. Okay? So, again, we're going to copy the diagram, only the important stuff that we need from the picture, and we're going to add the stuff that we know has to be true. Okay? So, here we go. If you remember, we got vertical angles again. Okay, so the vertical angles are going to be LMK or KML, either way you say it, and NMP, this angle right here. So what do we have now? Well, guess what? This time we've got an angle, a side, and an angle. And this time the angle is the included side. So you guessed it, that is angle, side, angle. We have now proven that triangle MLK is congruent to triangle MPN by the angle, side, angle congruence postulate. Then, because of our friendly new acronym that we just learned, corresponding parts of congruent triangles are congruent, we know that NP is going to be the distance across the river, is going to be the same as that distance that we can now measure on land, namely KL. Pretty cool, huh? Well, I'm hoping that you can see from this video that we can actually use this stuff, you guys. I know we're saying that we can never use any of these things we learn in a math class, but you know what? You remember those conditional statements? If we learn it in a math class, then we'll never be able to use it. Yeah, we just disproved that, didn't we? So we can never say we're never going to use this stuff again. Doggone it. Now we have to stop saying that. Well, I hope you enjoyed the video, guys. Let's come ready to do some more examples in class and use this information. You guys have a great day, and we'll talk to you later.